Hello students, from today onwards, let's start gravitation. It's a very important chapter for class 9 and at the same time it is also a very interesting topic. So let's learn gravitation. So this is the first question for today's class. What is gravitation? Actually, gravitation is a general term and it means the force that exists between two objects having mass. The force which attracts the two objects, that force of attraction is called gravitation. So now we can write the definition here. Gravitation. The force of attraction that exists between two objects having masses. The force of attraction that exists between two objects having masses is called gravitation. Or you can call it gravitational force. That means gravitation or gravitational force pulls the objects, the two objects together. Then also you can write that is gravitation pulls the two objects together, and it is a general term like this. So whenever we say gravitation or gravitational force, it means it is a force of attraction between two objects having masses, and is a general term. The two objects can be any objects, but when one of them is Earth, then we cannot use this term gravitation. In case of Earth, we sense this name gravitation into gravity. So actually gravity is also one of the gravitation, but if one of the object is Earth, then the force of attraction of the other objects by the Earth, that force of gravitation is called gravity. So from this we understand gravitation is a general term, whereas gravity is not a general term, and it is used only when one of the objects is Earth. So now let us continue the next question. Question number 2. What is gravity? One more. In question number 1, we discussed about gravitation, and we know gravitation is a general term. General term means it is a force of attraction between any two objects. But when we use this word gravity, gravity is not a general term, even though it is also a gravitation, means a gravitational force, but it will be used only when one of the object is Earth. So we can write the answer here, gravity. The force of attraction of an object by the Earth is called gravity. The force of attraction of an object by the Earth is called gravity. So, gravity is also a gravitational force. This is gravitation. And is used only when one of the object is Earth, like this. So from these two question answers, you can understand the difference between gravitation and gravity. Gravitation is a general term for attraction between any two objects, whereas gravity is the force of attraction of any other object by the Earth. That it means it can be used only when one of them is Earth. But in first case gravitation, the two objects can be any objects. There is no restrictions. But in case of gravity, one of them should always be Earth. So like this is gravity and this is gravitation. And I think you understand. So anyway, it may be gravitation or it may be gravity. They all are force of attraction. Then after this, let us continue. Newton's universal law of gravitation. After knowing that any two objects, when we give any two objects, then there is a force. That force pulls the objects together. That force is called gravitation. And this was learned by Newton, and he established a law, and that law is called Newton's universal law of gravitation. Let us see what is that Newton's universal law of gravitation. Let us discuss along with question. State Newton's universal law of gravitation. The word universal should be there. State Newton's universal law of gravitation and derive the relation F equal to capital Z, capital M, small m, d square, where F is the gravitational force and capital M and small m are the masses of two objects and d is the distance between the two two centers of the two objects, and lastly capital Z is universal gravitational constant. Like this. This is the question. I'll read out once again. State Newton's universal law of gravitation. 1 mark. Very important law. And the second part of the question is, and derive the relation to F is equal to capital Z, capital M into small m divided by d square. Where capital F is the gravitational force, capital M and small m are the masses of the two objects, and d is the distance between the two centers of the two objects. And lastly, capital Z is the universal gravitational constant, carrying 3 marks. Let us solve the question. Okay, then let me wrap the question since we know the question. Now, let us make the answer here. Answer. Newton's universal law of gravitation. Newton's universal law of gravitation states that everybody in this universe attracts every other body. With a force which is directly proportional to the product of masses of the two objects and is inversely proportional to the square of the distance between the centers of the two objects. So this is Newton's universal law of gravitation. Let us see once again. Newton's universal law of gravitation states that every body in this universe attracts every other body with a force which is directly proportional to the product of the masses of the two objects, number one. And then it is inversely proportional to the square of the distance between the centers of the two objects. This is the second part of Newton's universal law of gravitation. So let us rough the statement of this Newton's universal law of gravitation, and then let us come to the second part of our question. That means derivation of the expression of gravitational force. It is like this. Look here. We'll draw a simple diagram like this. Suppose this is an object. You can call it A. This is the center of the object. Let us take here another object. You call it B, two objects or two bodies, A and B. The mass of this object A is capital M, and the mass of this object B or body B is small m, and the distance between their centers from here up to here is represented by D. D means the distance between the centers of the two objects A and B. Then we can start. Derivation of the expression F equal to capital Z capital M into small m divided by D square. So you can start writing like this. Let us consider two objects or two bodies of masses capital M and small m respectively, and these the distance between the centers of the two objects. Simply like, let us consider two objects or bodies. Let us say bodies A and B of masses capital M and small m respectively. And they are and let D be the distance between their center. Let us consider two bodies A and B of masses capital M and small m respectively, and let D be the distance between their centers. By Newton's universal law of gravitation, the gravitational force F. And after this, we continue like this. By Newton's universal law of gravitation, the gravitational force capital F. Capital F is a gravitational force existing between the objects A and B. That it means object A pulls or attracts object B towards the center. Similarly, object B also pulls object A towards the center. And that force of attraction is called gravitational force, or simply gravitation, represented by this capital F. And according to Newton's universal law of gravitation, that gravitational force or gravitation F, by Newton's universal law of gravitation, the gravitational force F, you can write like this: F directly proportional to the product of their masses. Capital M into small m, this represents the product of their masses. So this gravitational force F is directly proportional to the product of their masses. It is given already in the Newton's universal law of gravitation. You call it relation number 1. And then again the same gravitational force is again inversely or indirectly depends on the square of the distance between the two centers of the two objects. So you can write it 1 divided by d square, because this is the distance between their centers. This is also according to Newton's universal law of gravitation. In his universal law of gravitation, already mentioned that the force of gravitation is directly proportional to the product of their masses, and then the same force of attraction is inversely proportional to the square of the distance between their centers. So we can write two proportional relations, relation 1 and relation 2. These two proportional relations we can combine it like this. Combining relations 1 and 2, we have F proportional to, in the numerator you have to write m into m, and in the denominator d square. This is called combination of the two relations, relation 1 and relation 2. And we can continue like this. Instead of writing this proportional symbol, we like to write equal to sign, because we want to make an equation like this. So any proportional relations can be converted into equation by inserting a constant. So let us change this sign into equality sign like this, and since this proportional sign is changed into equality sign, we have to multiply by a constant, and let us use this capital G as the constant of proportionality. That it means m into m divided by d square. When it is multiplied by capital G, this relation is converted into an equation. So F is equal to capital G, capital M, small m divided by d square. This is the required expression. Here, capital G is equal to a constant of proportionality. And is called the universal gravitational constant. Like this. We can stop here. So in this manner we can establish the expression for gravitational force, that is capital F is equal to capital G, capital M into small m divided by d square. This is the relations given by Newton's universal law of gravitation. So I think you understand this is very easy. Use Newton's universal law of gravitation, and from the law itself, first you write down the two relations, proportional relation, relation number 1 and relation number 2, and in next step you combine the two relations, then you will get this, and then in the last step you convert it into equations by multiplying a constant, and that constant you cannot use any other symbol except this capital Z, because it is fixed, and this constant of proportionality is also called universal gravitational constant, like this. So now we like to know the numerical value of this universal gravitational constant, as well as the international SI international system of unit. This G also has its own unit. That also we like to know. So next question we are going to discuss the numerical value of this capital Z and its SI unit. I'll write the question here. what are the numerical value and SI unit of Z? Carrying 1 mark. The numerical value of capital Z is experimentally determined by Henry Cavendish, and it is found to be 6.67 into 10 to the power minus 11. This is the numerical value, 6.67 into 10 to the power minus 11. And its SI unit is Newton meter square per kilogram square. And this is the unit, SI unit. This is the unit, and this is the numerical value. Numerical value is 6.67 into 10 to the power minus 11, and its SI unit is Newton meter square per kilogram square. Anyway, for this numerical value, you have to get it by heart. And regarding this SI unit, no need of getting by heart. I will write here. Look, F equal to capital Z, capital M into small m divided by d square. This is the formula for gravitational force. And from this gravitational force, you write the value of Z in terms of capital F, capital M, small m, and d square. That it means you write Z like this, capital F into d square divided by capital M into small m. By using this formula, if you want to write down Z, then you have to write down like this, according to mathematics. And then remember, what is this F? F is force. And for force in SI unit, could you tell me the unit for force? Unit for force is Newton. We can write simply capital N. Instead of writing in words, Newton is the SI unit of force. And after Newton, what is this? D square means distance square. Distance is measured in meter. So here, since it is meter square, D square, so here we have to write M square. Distance is measured in meter, so d square means m square. And then you look, what are these things? This is also mass, this is also mass. Two masses are multiplied. For the first capital M, it is also measured in kilogram. Next also measured in kilogram, kilogram into kilogram. Then you can write Newton meter square divided by kilogram square. But we like to write like this, m square kilogram. This kilogram square is denominator, but if you want to write in a numerator, then you have to put 1 minus sign in front of its power. Then Newton meter square per kilogram square. Same, Newton meter square per kilogram square, like this. So this is the SI unit of Z, like this. You compare with this and this, same. Newton, meter square, kilogram, minus 2. Like this, every unit, they are derived from the corresponding equations or from the corresponding expressions. In this case also, the corresponding equation is F is equal to Z, capital M into small m divided by d square. You write down the value of Z in terms of F, D, M, and remember their SI units, put them together, fit them together, and at last we get Newton meter square per kilogram square, like this. This is how we find out SI unit of universal gravitation constant. And I think you understand it. And then, now, question number 5. Let us see this question. What is free fall? Suppose an object which is kept some height just above the surface of the earth and you let it fall. But in that case, let us think that, or let us suppose that there is no air, so that no resistance is given to the object, and that means the object is falling only due to gravitational force of the earth. That type of fall is called free fall. That means free fall is nothing but is the falling on an object under the gravitational force alone. No force is not allowed to play a role during the time of falling of that object. Only gravitational force of attraction is allowed to play a role. So you can write like this: free fall. Free fall. Suppose this is a small object, it is falling towards the earth, and this is earth, this is center of the earth, and this is an object downward journey. So such type of downward journey of an object due to gravitational force alone. No other force has no role to play in such a case, means they are all absent. We're assuming in that sense, only the gravitational force exists. So the downward journey of an object only under the gravitational force of the earth. That downward journey is called free fall. So we can write like this: the downward journey of an object under the gravitational force alone is called a free fall. So in case of free fall, you can take only the gravitational force, it is playing a role. Because of the gravitational force, every object is falling downwards towards the center of the earth. And in such a case means in case of free fall, no other force works on that object except the gravitational force. This type of downward journey of an object under the gravitational force alone is called a free fall. So this is the definition of free fall. And after knowing the definition of free fall, let us see what is acceleration due to gravity. Symbol is small c. You know the definition of acceleration? Whenever an object is acted upon by a force, and because of that, if the object moves, then its velocity keep on changing, and because of that, it produces an acceleration. Because acceleration is the rate of change of velocity. Here also we have acceleration due to gravity. This is also acceleration, but it's caused by gravitational force of the earth. Because of that, we use the word gravity, acceleration due to gravity. We're not saying only the acceleration. After acceleration, we used to put due to gravity, because that is produced by gravitational force of the earth. So that we're going to define it. Let us see. So you look, the same diagram, this is an object, it is falling towards the surface of the earth, is because of the gravitational force of the earth. Gravitational force of the earth pulls this object downward. And since this object is acted upon by gravitational force, it is acted upon by gravitational force. Let us use capital F. And it is moving downward, that it means it is moving towards the center of the earth, and so it is associated with an acceleration. That acceleration is denoted by small g. And so now, could you tell me this acceleration g is produced due to the gravitational force of the earth? That it means this g is produced by this gravitational force of the earth. And you will see in the downward journey of this object. This acceleration is called acceleration due to gravity. You can write like here. WCELER. Acceleration due to gravity. Symbol is small g. Acceleration due to gravity is also an acceleration, but it is produced by the earth gravitational force on an object. Because of that, we call it acceleration due to gravity. The uniform acceleration produced in an object due to the gravitational pull of the object by the earth is called acceleration due to gravity. Due to gravity. Small, like this. Only one sentence. Acceleration due to gravity is a uniform acceleration produced in an object due to the gravitational pull of the object by the earth is called acceleration due to gravity. The value of acceleration due to gravity is different from place to place, but some average approximate value we can by heart. Not the average value of z near or on the surface of the earth let us write meter per second square. The average value of z near or on the surface of the earth, you can take it 9.9 meter per second square. And z, it can be positive or it can be negative. In case of downward journey, you can take it positive, and in case of upward journey, you can take it negative. So here, let us put like this. For downward journey. Downward journey means for falling objects. And you have to take minus sign. Numerical value is same. Minus 9.9 meter per second square. This is for upward journey. For ascending object. when you drop something against the gravitational force, then in that case the value of g should be minus 9.9 meter per second square. And in case of some object which is falling towards the center of the earth or towards the earth's surface, in that case you can take the value of g as plus 9.9 meter per second square. So you should not forget, during mathematical calculations, the value of g should always be 9.8, but its sign should be plus if it is a downward journey, and its sign is minus if it is an upward journey. Upward journey means against the gravitational force of the earth. Next question is, distinguish between capital Z and small z. Let us give 3 marks. Let us write down like this. First one, you know capital G is called the universal gravitational constant. It is a constant. It is a constant. And its value is same everywhere. It is a constant and its value is same everywhere. And you can write this value 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. This is the value. And on the side of small z, it is not a constant. It is an uniform acceleration. And its value varies from place to place, from place to place. And its approximate value is 9.8 meters per second square. Near or on the surface of the earth. Like this. This side capital Z is a constant and its value is same everywhere and its value is given here. The other side small z is an uniform acceleration and its value varies from place to place, and you can take z is equal to 9.9 meters per second square approximate value near or on the surface of the earth. Point number 1. Point number 2. It is a scalar quantity. Because it has only the magnitude but no fixed direction. Number 2, on the side of small z, it is a vector quantity. Why it is vector quantity? Because it has its magnitude as well as its direction. Because of that, It is called a vector quantity. Point number 3. Capital Z can not have cannot be negative nor zero. Capital Z cannot be a negative nor cannot be zero. And this side for small z can be positive or negative or zero. For acceleration due to gravity small c, it can be positive, sometimes it can be negative, and sometimes it can be zero. But here it cannot be a negative as well as it never be a zero. It cannot be a zero. Like this 3 points, 1 mark each. So these are the differences between capital Z and small z. Then let us see the next question. Let us derive an expression for acceleration due to gravity. Derive the expression small z is equal to capital Z, capital M divided by R square, where capital Z is equal to universal gravitational constant. The universal gravitational constant capital M is equal to mass of the earth, capital R is equal to radius of the earth. And Z is equal to acceleration due to gravity. It is also asked frequently in the examination. Expression for acceleration due to gravity small z is equal to capital Z, capital M divided by R square. Answer. Let us see. Let us take a small object on the surface of the earth or near the surface of the earth and then earth. This big circle represents earth and this small circle represents a small object. Let us call the mass of this small object small m and the mass of the earth capital M, like this. And since this small object, when you compare the size of this small object with the size of the earth, it is so small that it cannot compare with it. So the distance between their center, approximately, you can take radius of the earth. R is the radius of the earth. So R is the radius of the earth, and you can take the distance between the center of the earth and the center of this small object. That also you can take it R. because to that radius of the earth, if you add some meters or some centimeters, it won't give any big sense. Because of that, we can take approximately equal. So the distance between the center of the small object and the center of the earth, you can take as the earth radius, equal to the earth radius. So you draw a figure like that. Let us consider a small object of mass m on or near the surface of the earth, and let capital M and capital R be the mass and the radius of the earth respectively. So between this small object and earth, there is a force of gravitational force of attraction, and that gravitational force of attraction, let us use capital F to represent that force of attraction. Now, the gravitational force of attraction of the small object gravitational force, let us write here F, of attraction of the small object by the earth is given by, let us write down, capital F is equal to capital G, capital M into small m, mass of the earth, mass of the object, and distance between their centers is equal to r, so r square like this. You call it question number 1. And let me rough the question. And now you remember Newton's second law of motion. From Newton's second law of motion, Newton already established the relations of force. Force is equal to mass into acceleration. Then we are going to apply it. When by Newton's second law of motion, we have this same force F is also equal to mass into acceleration. Then you put their values. Mass is not the mass of the earth, but this is the mass of the small object, because force is acting on it, into acceleration. In this case, it is called acceleration due to gravity, so we'll use small g. This is relation number 2. Then from this relation 1 and 2, you will see in relation 1 is also, it is the value of F. Relation 2 also, it is also the value of same force F. Then you can compare it. Now you continue here from equations 1 and 2. We have mg equal to capital Z, capital M, small m divided by r square. On both sides, mm cancel. So on the left side we have only acceleration due to gravity, and the right side we have capital Z, capital M, r square. So this is the required expression for acceleration due to gravity. So now this acceleration due to gravity small z is also equal to capital Z, capital M divided by r square. Capital G is universal gravitational constant, capital M is the mass of the earth, and capital R is the radius of the earth, like this. After this, let us see a very short question answer for today. As you know, the value of z varies from place to place. So now we like to know the minimum and maximum value of z, acceleration due to gravity. Along with question, let us discuss. Where is the value of z? Roman number 1, maximum. And Roman number 2, minimum. Answer is maximum value of z. The value of z is maximum on the surface of the earth. Maximum value you will get on the surface of the earth. Z is maximum on the surface of the earth. Roman number 1 is finished, and Roman number 2, minimum value. Of z. The minimum value of z you can find at two different places. One is at the center of the earth. At the center of that, minimum value of z is 0. 0 is the minimum value of z. So minimum value, that means 0 value of z is available at the center of the earth as well as at infinity. At infinity means a very distant place. You can write z is minimum. Minimum here it means 0, that is 0. Either at the center of the earth or at infinity. So now maximum value of z, it is available on the surface of the earth, and a minimum value of z, it is available in two places, one at the center of the earth and another one at infinity. Infinity means at a very far place from the earth. So these are the minimum and maximum values of z. So for today, let us learn up to this, and in the next class, let us continue this same chapter. So for today, let's wind up here.